Students get confused when it comes to the average problems, mainly because many students do not realize the averages cannot be averaged. Let me show you a case here. Oh, so what do I mean by averages cannot be averaged? Let me show you one case here. Suppose you have a water somehow pushed up like that, and you're about to let go of this dam here, and the water will flow down. How high would the water settle on this case? You can think of this as ice shaped this way. After it melts, what would it look like? It would look like something like this. Water level would be around there. Okay, I think everybody will agree. Nothing wrong with that. But let me ask you another question. What if the ice shape or the water was walled off like this? And after you let go of this wall that separated this water here, how high would the water be? Would be here. Okay, so what does that got to do with the average problem? Well, it's got a lot to do with the average problem because of this. On this problem here, the average of these two numbers, the average of this number is 10. And average of these numbers is 2. So I could give you problems that would fit to this. I will do that a little later. But we got one set of numbers, average is 10. The other set of number, average is 2. When you average them, when you average everything, what's the average? It's not 6. It is this, 2.5. Huh. Okay. Now let me give you a different case then. What if I gave you something like this? So what situation is this? Well, average of these numbers is 10. And average of this number is 2. So what's the average of the total when one part is 10, the other part is 2? The answer is up here, 9 point something. Wow, look at these two cases. We had it seems like they were somewhat identical, dude. Well, one of them was 10 and 2. The other one is 10 and 2. And yet, when I show you this way, you can tell it looks radically different. And so are the answers. Answer will be radically different. One is like this, the other one is like that. So the key to understanding this average problem business is realizing that you cannot just average the average. Can you ever average the average? Yes, there's one case you could average the average. That's when they're equal. What I meant is this one. In this case, the average is 10 of those numbers, and the average of these is 2. Notice here, I got 8 of this, and I got 8 of that. Now they are even. So therefore, you could average the averages and get the answer, which is 6. Yes, but only then. That's the only case. But it doesn't happen often, and you can bet. In your tests, you will never get that case because it's too easy. Everyone would get it. And, your test givers don't want that. They want to see who can differentiate this and get it correctly. Okay, so now that I told you what not to do, I'm going to tell you what to do. So then, how can we do this problem? How would the problem come out? Well, let me show you. It comes out like this. So Octavio scored 10, 2, 2, 2, 2. Basically, I'm telling you how high these are. 10, 2, 2, 2. So this water suddenly becomes your score, test score. What is this average? Well, pause this module and do the problem. And do the second one too, and then come back after you're done with these two. Okay, hope you're not cheating on me. You did them, right? So you just add them, right? You know how to find the averages, the means. Just add them all, and what do we get? Well, there's 110, the rest are 2s, and there are 15 of them. Everything is 16. One is missing, so must be 15. So we have 10, the first guy, and the 15 times 2 is 30. Out of what? 16 numbers. What's that? It's 40 over 16. Now let me divide by 8. 5 over 2. So that's 2.5. So the average will be 2.5. What does it mean? It means it will look like this, that height. It makes sense, right? You can intuitively feel that way. I don't know what answer you got for the second problem. It was identical problem to the first one. But instead of listing all the numbers for you, they said average of the first one is 10. The average of the 15 of them was 2. So many students would just go ahead and average 10 and 2 and get the answer of 6. Do you think water would rise that high? No way. So then how do you do this? You got to find the total. That is, when they ask you to find the total average, you have to see how many tests there will be altogether. There were 1 test, there are 15 tests, so it's 16 tests altogether. Let me be abundantly clear and show you where it came from. There were 1 tests and 15 tests. Okay, what did you get the total in the first test? There was only 1 test of average 10, so average times number of tests. That's how much you got, or how much Adriana got. And how much did she get on the subsequent 15 tests? She took 15 tests, average of 2. So therefore, she got 30. So in other words, we are finding how much she got total here. So it's 10 plus 30 over total number of tests, 16. So the rest is, well, it looks identical. The answer will be identical. It's 5 over 2. Once again, it's this height that I was telling you about. Okay, so that's the average score. It's a pretty sad situation. So let's change our situation to something more uplifting and more positive. What could that be? Well, some other higher score. This is one that I showed you, right? And problem would not be this anymore. It would be this instead. So let's do this problem here. That's score averaged 10 on first 3 tests, or 3 tests. What does it mean? On 3 tests, it was 10. Then averaged 10 on 4 tests. You may say, oh, what's the point of breaking like that? They're all the same. Well, teachers would break like this to confuse the students. It's not confusing when you look at the diagram like this, but it's confusing when you look at this. And 10 on 8 tests. So here it is. And 2 on 1 test. So here it is. What's his average? You know, just because I wrote like that, many students will start averaging 10, 10, 10, and 2. Should I do it? They start saying, okay, 10, 10, 10, and 2. Then divide by 4 and think they would get the right answer. Of course not. It doesn't work that way. If it's not that clear why it doesn't work that way, let me show you here. The same problem could be written this way. Satoshi's average was 10 on first 15 tests and 2 on the 1 test. Okay, so here's a 15 tests with an average of 10 and 2 on the last test. In other words, these two are identical problems, just presented differently. And many students would go ahead and average 10 and 2 and get the answer of 6, which is very wrong. Would not be this, right? The true average would be this high, actually. But how do you show that? How do you compute it? Once again, you got to do total over total. Let's find the total score. Let's do for this guy first. He got 10 on 3 tests. And then he got average of 10 on 4 tests. And he got average of 10 on 8 tests. And 2 on 1 test. Okay, that divided by 16 is the answer. Now let's do the bottom one here. Satoshi's average was 10 on 15 tests and 2 on 1 test. How many tests is there? 1 and 15 and 1 makes it 16. Wow, would these two give me the right answer, the same answer? Yeah, because the top, I could group these things with factor of 10, you see. Then I would have 3 plus 4 plus 8. That's what I would have. When you add them here, you get 15, so it's the same as this. So I will just do the bottom one here. It's 152 divided by 16. Once you crank out the number, what do we get? Let's divide by 4. And then divide by 2. So the answer is 9.5. Okay, 9.5 is the height. So that's how you do the problem. Okay. Now, do we feel we know what to do? Shall we see if we can do actual problem. I'm going to give you a problem and a situation and see if you can do this by yourself. So the problem is this, not this. Problem is this. I kindly drew the diagram for you. Why don't you pause and do this problem on your own? Okay, are you back? You must have done it. You should have done it. Don't think that you can just watch this and get it. If you didn't, pause now and do it. Otherwise, you're wasting your time. Okay, Casilda scored 5 on her first 3 tests. We see a score of 5 on first 3 tests. You know it's going to give us the total of 15. So why don't we save time and write it? And scored 8 on her 5 tests. So there are 5 tests and she scored 8. So she got 40 points here. Due to her circumstances, who knows what happened to her, she was not able to study and received only 5 on the next tests here. Next 4 tests, I missed it. So if you did it and couldn't get it right, maybe you should go back and do it again. So there's 8. Okay. Then she scored 10 on the next test for a change. So scored 10. So this is the total we have here so far. Her final test is worth 3 normal tests. You know, these things kind of throw off students how to do these things. It just means whatever she scores will be worth 3 times as much. One easy way to think about it is to have 3. Like that. 3 slots. So whatever she gets here will be taking 3 slots. What should she score in the final so that her average will be 6? We want her average to be 6. So how should this go? So that when all these things melt, would fit the pool at that height. Well, shall we do the problem? So got to be total over total, right? There will be 16. Well, she had only what? 13 and 14 tests. So because the last one was worth 3 times as much, it ends up being out of 16. And then she had 15, and she had 40, she had 8, she had 10, and the last one, we do not know. Whatever score she has to get is 3x. That should be equal to 6. So if you add all this, where should we do this? Well, let me multiply 6 with 16 here. So there's no point in dividing 16 and 6. That would be 96. Okay. Let me get rid of this. Okay, let's add them. What do we get? 50, 65, 73. So 3x is equal to 23. X equals 23 and 3, 7. So it will be 7.666 repeating is her score. So that's how you do this type of problems.